You're good to go.
Okay. Okay, so hello everybody. Um, Welcome to today's session where we'll be going over the topics of Polkadot, Parachains, and Substrate at a high level. So welcome to this talk. So at a very high level, if I have to introduce Polkadot to you, I would call it as a heterogeneous multi-chain that connects and secures blockchains with pooled security and interoperability. So these are the key terms that we'll be exploring in depth in today's session. One is the security, and the other one is interoperability. Okay, so broadly speaking, Polkadot provides security for sequential parachain blocks in parallel. So the logo that we share almost everywhere, it has this graphic has a bunch of parachains that are over here, which are running in parallel. All of them are submitting their blocks to the relay chain, and so in today's session, I'm going to explain like how those blocks get finalized, and how all of these individual parachains, which are blockchains, are going to interoperate in harmony. Okay, so the key features of Polkadot are, so one is the interoperability aspect, which is like connecting the blockchains together. The second one is handling like traffic at scale. So we're talking about 100 or more, even potentially more parachains that sort of talk to each other and to the relay chain. And yeah, so the industry leading security. So Polkadot uses nominated proof of staking, which I'll be going over in a little bit of detail and show like why the parachains are secure on Polkadot. So the other interesting feature the Polkadot ecosystem has is being able to create these blockchains, which are very customizable. And so we have the governance, like one of the really sophisticated governance systems in across like blockchains out there. And finally, I'm going to talk about the forkless upgrades. The way you can upgrade a blockchain without having to fork. All right. So a common misconception like people generally have is that Polkadot is like a layer one blockchain. They keep comparing Polkadot with like Ethereum or so other layer one blockchain solutions out there. But I want to clear that misconception right now. Polkadot is a layer zero blockchain, meaning all the blockchains that you see, which are layer ones, they can sit as parachains on Polkadot. So Polkadot is the underlying layer, which is going to facilitate all these layer one blockchains to talk to each other. And also it provides security for them. So these individual parachains, so these are third-party chains that connect to Polkadot for interoperability, scalability, and pool security. Um, Now, I'd like to highlight that the technology that powers Polkadot and most of its parachains is Substrate. So we'll be talking about Substrate as well later on, but this is a good time to introduce to you that there have been like multiple blockchains that are built using Substrate, which have become parachains on Polkadot, or are planned to become parachains on Polkadot, or they can be solo chains as well, without having to do anything with Polkadot ecosystem. So here we have plenty of applications that were built on Substrate. And if you ever want to get started with any of these, like DeFi, NFTs, smart contracts, identity, etc., take a look at the projects that are already out there. So their code base and their features are going to give you a good insight into where exactly people are in terms of implementing features and functionalities. All right. So if you have never interacted with the Polkadot network, one gateway is the Polkadot.js apps. So if you go to this link, I hope you've received the link for this presentation. So the presentation has plenty of these hyperlinks. Feel free to click on them and then see everything for yourself live. Yeah, so this snapshot was taken like early today. You can see that there are over 10 million blocks on Polkadot. The chain is live and running with the block production time of like 6 seconds. So every 6 seconds, a new block is being added here. And then we have the validator who is, adding that block to the blockchain right there. And this screen gives you a good, insight into the events that are happening uh, that are packaged within each block. So check out all these, tabs that are out there, which will let you peek into, what's happening with Polkadot Network. And regarding the decentralization aspect and in terms of like geography, you have nodes. I mean, Polkadot Network has nodes spread across the world, and the way you can get an insight into this is using the telemetry link right there. So it's going to show you not just like Polkadot Network, but also all the all the nodes and projects that are being developed on Polkadot ecosystem. So you have like Kusama, which I'm going to talk about later on, and all the Parachain projects as well. So they use this telemetry tool to monitor their nodes. In terms of like functionality, like Polkadot has come to fruition like last year, around like October. Like there was an announcement saying, Parachains launch is live. So that's when like we had these auctions to get like Parachains plugged into the Polkadot relay chain. Yeah, so it's sort of like fairly new, and then there are a lot of exciting features and functionalities that are being enabled and developed. So it's like a very evolving like ecosystem. And yeah, so I'd like to highlight that. But the development of Polkadot has been for 3 years. So it was last year that we finally saw the fruit of all those all that development. So yeah, again, if you go to Polkadot.js and then take a look at the parachains, so go to the network and go to like the Parachains tab, and you would see all the Parachains that are plugged in to Polkadot. So right now there are around 14 Parachains and then 14 Parathreads. So these are the projects that are planning to become like Parachains. I'm going to talk about Parathreads in detail like later on when I talk of like Polkadot architecture, but these are the projects that have registered, uh, and eventually they will auction to become like Parachains on Polkadot. So there has been like significant progress since like October. A lot of projects have bid to become like Parachains on Polkadot, and there are more in the pipeline. Okay, so this is another area where I want to remove the misconceptions. So about Kusama. So Kusama is an independent blockchain. Okay, so it's independent from Polkadot. It has its own like governance. It has its own token, and it has its own like unique community. Although there might be overlap between Polkadot and Kusama community. So Kusama is like a very experimental blockchain network, and it's not a test network. It's a canary network. So there's a huge difference between both of them. So test networks, the tokens of test network or anything that happens there has no economic value, but Kusama has real economic value associated with it. And this is sort of like a unique thing about like Polkadot ecosystem, where projects can leverage on Kusama's experimental nature and deploy like their features much earlier on Kusama, test it out in the real world, scenario, see if people are taking advantage of the code, even though your code might not have any bugs. um, you know so the logic itself can be tested out in a real world economic scenario. right? So that's a huge value addition for you as a developer. So if you're planning to create like a successful project, a blockchain project, having a blockchain network like Kusama is going to give you, a lot of advantage. So in terms of like the network, the code itself is uh, similar to like Polkadot, or even in fact a little advanced than Polkadot, because all the new features, that are experimental, are first going to be deployed on Kusama Network through Kusama's governance, and those features are tested out, for possible bugs, for possible uh, events that you don't foresee when you develop those features, and only when things are working smoothly, those features are moved to like Polkadot Network. Okay, so feel free to explore Kusama Network as well. Kusama has launched earlier than Polkadot for the obvious reasons. It has over 12 million blocks already, and pretty much most of the parameters that you see on Kusama match with like Polkadot. Okay, so the block production time is just 6 seconds, and yeah, plenty of the pallets or the code on Kusama is the same as Polkadot. Okay, so because Polkadot, follows Kusama, like even literally, even if you go on Twitter and see, Polkadot's account, you see that it's kind of following Kusama, right? So Kusama has started its journey into, interoperability, scalability, and security provision much earlier than Polkadot, and it's already the home for over 32 parachains. Okay, so this snapshot was taken today. Again, like there are over 16 projects which have registered their interest to become like parachains on Kusama as well. So the ecosystem is growing at a rapid pace. I'm going to talk about a little bit about the lease periods, auctions, and crowd loans like later on. But yeah, so there is interest in being a parachain on Kusama as well. Okay, and yeah, so I couldn't fit the entire list of parachains right here, but most of these projects, which have become parachains on Kusama, have also active bids to become parachains on Polkadot, or have already secured like a parachain on Polkadot. Okay, so again, let's revisit the features that I've talked about, individually. So the first thing is connecting networks together, right? So how does Polkadot facilitate blockchains to talk to each other, and how different it is from blockchains talking over bridges, right? So you would have heard of so many hacks over the past few months regarding like a hack on this bridge, that bridge. So let's see how Polkadot sort of enables these blockchains to talk to each other trustlessly, without the fear of such hacks. All right, so with that, I just want to mention that blockchains in general that are good at doing a single thing, maybe like Bitcoin. It's a distributed ledger. It keeps track of all those accounts and transactions, and that's it. So this could be like a custom built parachain on top of Polkadot, right? So blockchains like Bitcoin can be a parachain on Polkadot, and also like you have blockchains that could do a lot of things. In fact, like blockchains that could do anything what your computer could do, right? Like Ethereum is Turing complete, sort of Turing complete in terms of like executing the functionalities. So Ethereum could do many things. So such blockchains can also be parachains on Polkadot, right? So we're talking about over 100 of these blockchains that are, over Polkadot, that are going to talk to each other, and as well as function independently on their own. Yeah. So just to mention, I've shown like all the application specific blockchains that were built using Substrate. So all of these parachains are those projects, ranging across several application areas. Now, so the the communication between these parachains is overseen by Polkadot. It's very different from communication with other blockchains, right? So this is going to be a bridge. So you're bridging two different like blockchains, um, like Ethereum. If applications on Ethereum have to talk to applications on Polkadot, so that has to be bridged. Okay, so this is the problematic area. um, Always, so bridging problem is difficult. It has been in the news for the past few months, with major blockchain developers saying that it's a very hard problem for obvious reasons, in the sense. So you have two different uh, ecosystems, or blockchains, with their own consensus, their own community, and sort of making sure like things are honored at both the ends. So that's a difficult problem to solve. But anyway, so how about having parachains on Polkadot, and then they talking to each other? Yeah, can that be sort of secured? The answer is yes. So Polkadot is developing several protocols, several message formats to ensure no such hacks could happen in here. Um, yeah, but again, there are plans to bridge uh, other blockchains, like Kusama. It's a relay chain, and Polkadot is a relay chain. So there are plans to bridge both of them as well by the end of this year. Yeah, so the key things, concepts about interoperability in Polkadot are XCM and XCMP. So one is a protocol, it's like HTTP, and XCM is more like HTML. Okay, so one is a messaging format, the other one is the protocol through which you communicate with each other. So XCM sits on the top, and then you have a bunch of cross chain messaging protocols right here. Um, I'm not going to go into depth on this slide. If you're interested to dig deeper, I've given several links here, and these two links point to the new Stack Exchange site that went live for Substrate and Polkadot. So feel free to explore, these questions in much more depth on our Substrate Stack Exchange. All right, so let's talk about what this thing means. This feature about enabling custom-made uh, platforms to be built for specific apps. So you can think of it this way. So blockchains on Polkadot, so they can be custom built, and they can also be optimized for specific use cases. Okay, so just think of music producers, or a DJ in a party. So they can optimize things in a way based on the music that's coming out, right? So there is a way to adjust weights and do a lot of customization in the substrate based code to give your blockchain very streamlined functionality to execute your application efficiently. So there is also this, you can think of Substrate having all these individual modules that you could use like a Lego bricks, where you can pick and choose what functionality you would want to include on your chain, right? So let's say you want your blockchain to have balances and accounts right off the bat. You can pick the balances palette. If you want your blockchain to have some governance, so with some governance primitives, so there's a module that you can directly include. And the good thing about that is you can sort of play around with these modules. What we call them palettes. So you're free to explore the code in there, and then if you don't like something, you're free to even modify the code in the palettes. Okay, so earlier I mentioned that Polkadot has a sophisticated governance model, which is kind of unique in the whole like blockchain ecosystem. So let's take a sneak peek into like a few of its features. Yeah, so the blockchains that are out there, so some of them may not have like any governance. It's basically like pseudo power for the developers. They decide the fate of that particular blockchain. um, or there could be blockchains where a single person or a bunch of so a small group of people decide the fate of the blockchain. So so Polkadot actually falls in this category. So we have like a very active community out there. The community proposes and votes on the decisions that impact the network's future. Okay, so uh, this could be anything from a small change of a parameter on the network to a change to the entire code base of the network. So all of this is proposed on chain. So nothing is done off chain. So all of this is done on chain. The proposal, the code, everything is on chain. The voting is on chain, and the execution is on chain. So to participate in the governance, like you need to hold the native token of Polkadot Network, which is DOT. So DOT holders, they can contribute to the future of the network in several ways. They can make proposals, which can become like referendums, which will be out for vote by the broader community. There is also something called as a council on Polkadot. So we have about like 13 individuals or like accounts that are elected as a council. So the council comes with few special privileges. It exists for a reason, but be aware that Polkadot has acknowledged that putting some level of power in like council is not good, for like the decentralization aspect of the network. So there are developments ongoing for governance 2.0. So that's going to sort of dissolve the council and make the governance even more like decentralized and streamlined. So there's also the existence of a technical committee. So right now, the technical committee is populated with the core developers of the network. So they're the ones who have the power to sort of shoot down malicious proposals to the network, and they can also like submit accelerated proposals, which can become referendums to be voted on by the community. Yeah, so if you want to check like governance on Polkadot, it's available through Polkadot.js apps again. So you can navigate to the democracy tab, and there you'll see a bunch of proposals or referendums that are currently active on the network. So we also have uh, kind of like an assembly place, like Polka assembly for Polkadot as well as Kusama. So feel free to check those resources as well. So that's where all the discussion regarding the Polkadot and Kusama governance happens. So we have people like discussing like individual proposals. So there are discussions below uh, the proposals in general on there. So if you'd like to learn more, so Polkadot Wiki is the key resource to understand governance on Polkadot. Yeah, so here is the interesting thing. So a lot of these proposals, along with the proposal text, they also have an associated code with them, right? So it's not like you propose something and after it gets executed, you upload the code for, making changes. So the proposal itself should carry a pre-image, which tells like exactly what this proposal is going to, uh, you know, do to the network. So this particular code is directly injected into the network once the proposal goes through. So this gives rise to a very cool feature called as Forkless Upgrades, which I'm going to talk like later on. But yeah, so the code is given along with the proposal. It is voted upon by the community, and once the proposal becomes a referenda and passes, the code is going to be executed by the network. All right, so talking about the security, let's talk about security for a while. Um, so you as a blockchain developer or a blockchain application developer, you can focus mainly on your application logic. You don't have to worry about securing your network or spinning up like these validator nodes. You know, so Polkadot sort of gives you that bootstrapping mechanism, right? So you as a developer can focus on your application and rent out like the network security in a way. So so how does Polkadot like even do that, right? So how secure is Polkadot? So to understand that, you have to take a look at the network's like proof of stake mechanism. Once again, like this is also one of the sophisticated proof of stake systems that is out there. So we use a fragment, a modified version of fragment algorithm to sort of like pick the validators. So currently, like Polkadot supports around like 297 active validators. So these are the ones that are going to produce blocks in an era. So each era lasts for a day on Polkadot, and yeah, so these validators are elected uh, through this nominated proof of stake algorithm. So people who are nominators, so they're going to nominate their dots on these validators, and the network sort of you know performs multiple optimizations and solves different objective functions to finally give a graph where a nominator stake is mapped to a single validator, or in rare cases multiple validators. And yeah, so all the validators that are who have like the maximum stake, so they end up becoming the active validators in the next era. So talking about like the network architecture, so as you can see, we have like Polkadot relay chain right here, and these vertical bars represent like validators who are on Polkadot. So I just mentioned there are around like 300 validators right here. So these are the ones that are assigned to the individual like parachains that you see here. Okay, so currently the count of the number of validators assigned to a parachain is 5. So there are 5 para validators who are sort of shuffled very often when they do para validation. So these circles that you see right there, those are collators. So collators are the ones who package the the transactions that are happening on a parachain into this proof of validity blocks that are sent to the relay chain validators. And the validation of those parachain blocks happens here, and the validators sort of include a candidate receipt. Okay, so they don't include the entire block that is sent by collators, instead a lightweight receipt in the relay chain. So the moment that gets backed and gets included, Parachain can know that their block is sort of finalized. Okay, so that's a very high level explanation of the sophisticated, um, you know, para validation that happens on Polkadot. But I hope you get the idea of how it's happening. And this particular part, the parathread pool, so it's an interesting concept where all these parachains are guaranteed throughput on the relay chain. So when they submit a block, the relay chain accepts that block. So if you don't want to win this particular slot, uh, you as a project have an option to become a parathread. So where so this is like an on-demand service. Like if you want your block to be included on the relay chain, you can like pay as you go. It's a pay as you go service where you're competing with other blockchains, that want to do similar things. So you submit that block, pay in dots, and then have it like included in the relay chain. So this functionality is not live yet, but it's one of the key priorities of the developers right now to enable parathread like functionality on Polkadot. So right now, if you want your parachain blocks to be finalized, you have to win like one of these individual parachain slots. Cool. So I just want to like highlight the thing that I just mentioned. As you can see, we have a bunch of validators assigned to a particular parachain, and you can see that they just got like shuffled. Um, Feel free to check that on Polkadot.js as well. So over a couple of blocks, the validators that are assigned to a specific parachain are shuffled. And the reason why I say this is industry leading security is that to become a validator in the first place, you had to have like a backing, from the nominators, and that nomination process. Once you're successfully have become successfully an active validator, then the network uses randomization like Babe. That's the algorithm name. So Babe sort of decides like randomly which validators are going to um, validate the parachain blocks. So to orchestrate any sort of like attack on individual parachains, you have to have a thorough understanding of how all of this is working, and and so there is no way that you can game the system to sort of attack a specific parachain, if that makes sense. So yeah, so Polkadot shuffles and assigns a set of validators to each parachain. So collators, who are the full nodes on a parachain, so they open connection with the relay chain validators, they submit a block, and the whole like validation begins. So I'm not gonna go too in depth about like the technical aspects of para validation, but I do want to highlight this particular thing, right? So I want to give you a brief idea of how the para validation happens. Okay, so think of like the state, the parachain state. You have a parachain with like balances. There's a democracy pallet on that as well. So something is going on with democracy right there. There's a council. So, and then there is like this Babe thing, which sort of may be used for selecting like collators, etc. In any way, so this is the parachain state. So parachain state lives as like a Merkle tree, where so all of these are hashed, and then they are hashed together, and then you have the state root. Now, in a given time frame, when you're packaging a block, there could be some events in the network. So let's say someone has sent some balance to someone else, and then something happened in democracy. Okay, so you have the next referendum in the queue. So these changes, okay, so they when the changes happen, okay, someone has sent balance to the other one, something happened in democracy. So those changes get reflected, in these specific like hashes, right? So the other ones, the validator count or balances of others or council, nothing has changed. So those remain the same. So the interesting thing is you need not send the entire parachain state to a relay chain validator. Instead, you could just send where there were changes, and then you can send just the hashes that were unchanged, uh, you know, between these two blocks. Yeah, so proof of validity is just that, meaning you don't have to send like the entire parachain state to the validator. Instead, you can just send these straight transitions. So if you have a valid initial state, and if the state transitions are valid, then your next block is sort of valid. Yep. So that's pretty much what is going to be sent by a collator to the validator, and the validator sort of validates that block, ensures that uh, everything is as expected, and the validator creates like a digest. It's called like a candidate receipt. So that candidate receipt is sort of stored on the relay chain. So it's basically a lightweight representation, a digest of the parachain block. So that's how, the relay chain state is not bloated. So the parachain blocks in themselves are not included on the relay chain. So they are added on top of like the parachain's blockchain, and the relay chain just holds like that candidate receipt. So if you're interested in diving deeper into those concepts, I suggest this article called Path of a Parachain Block. Um, so, so it gives you a very good overview of how all of this happens. Okay, so and here is my most favorite like feature of Polkadot, which is like self upgrades or forkless upgrades. Um, so it's almost like a magic, if you ask me. Meaning, you can start with a blockchain that looks like this, that could have functionalities like this, and then just with like an extrinsic, meaning so extrinsics are these transactions that you can submit as a user to the blockchain network, right? So there is actually a set code functionality there where you can actually set the runtime logic, the actual state transition logic of the blockchain itself through just a transaction. And so you can change a blockchain that looks like this and into this one on the fly. And there is even a demo, so if you're interested, like, check that out. And just to give you a sense of like what happens in other blockchain networks versus like what happens on Polkadot. So take a look at this. Like, you have this blockchain, and whenever a feature is not agreed upon by a significant section of like these nodes or validators, so they tend to like fork off, right? So this a significant group of like nodes believe that this is the canonical chain, and the other significant part can believe that this is the canonical chain, and then they keep adding blocks to that, right? So such bifurcation or forking is not possible on Polkadot, and the reason for that is the the state transition logic. Okay, so that lives on the blockchain itself. Meaning, so the state transition logic, the logic through which the new block is packaged, the new transactions are processed, all that code is part of the block itself. So when an extrinsic with set code gets passed and the code on the blockchain itself like changes, so the next block will be validated using that particular code, right? So basically the validator nodes, who are creating like new block, so they themselves don't have the code to do it like on the node instead. So it's there on the the previous blocks like runtime itself. So they're going to use that and then create a new block, which is a very clever design, which facilitates like these forkless upgrades. And again, like if you want to try it on your own or check out like the concepts, feel free to go to this link, and it gives you a technical explanation of what I just did. Yeah, and then I want to highlight this, like, all these Polkadot parachains, all of these are possible because of Substrate. So Substrate is the underlying technology that is sort of empowering like Polkadot ecosystem. So I'd like to spend some time explaining about Substrate as well. So Substrate is a modular, flexible, and extensible framework. So modular, so I mentioned about Lego bricks before. So every individual module, which we call like Pallet, is out there. So there are last time I checked, over 100 pallets out there, which are like a plug and play kind of modules. So you can include them in your blockchain application and then make them work right off the bat. And it's flexible. Okay, so you can choose one palette over the other, and also extensible. Like you can extend the features of a certain palette or the core primitives of Substrate itself. So Substrate offers this battle tested libraries. All of the blockchains applications that you saw earlier are running successfully out there, so you can use the same technology and then add on top of it. And you as a developer, so you would be initially focusing on Frame. So Frame is a set of modules and support libraries that simplify runtime development, right? So you as a developer would want to focus on the application logic of your blockchain. You wouldn't want to build everything from scratch, like networking layer or consensus. So if you don't want to bother about any of those and just focus on, let's say, DeFi, so you're building a DeFi application, you can just focus on that application logic and then sort of leverage on the Frame set of libraries and start building your application. So to make your life easy, Substrate ships with like a template node. So that is the starting point for most of the developers. You download the template node, you check like how the blockchain node is working, and you check out like the Substrate frame. Use the pre-existing like libraries to see if you can implement your application. And if you're not very convinced or satisfied with the performance of pallets that are offered here, you could also change things at very fundamental level. Okay, so you have the technical freedom to do it, and you have the development ease, where it's easier to start with this than changing things at the code level. So a brief visualization of how you can pick and choose like pallets into your runtime. So there are a lot to choose from. You can pick these pallets and then include them in your runtime. So anatomy of a Substrate node. So Substrate itself relies on like WASM for executing like runtime logic. Excuse me. So WebAssembly is deemed to be like the future of like blockchain technology. So right now everyone is using like EVM. If you've been following like developments in Substrate, you can see that we have Ink, which is like a smart contract authoring tools that are out there, so which are WebAssembly based. But anyway, so you have that, and then all the runtime logic is like a WASM blob that sits on your blockchain runtime. And yeah, so Grandpa is like the consensus algorithm. So this was developed by Web3 Foundation researchers. So that's where I'm giving the session from. So yeah, so all of these are tested, and all of these can run like right off the box. Yeah, so a brief overview of how things are arranged. Yeah, so you have like an RPC server. So you have telemetry, which is going to give you the health of your node, so you can check the metrics of your node. So for networking, like Substrate use lib peer-to-peer like protocol. So this was developed by the people who developed IPFS. Yeah, so yeah, so you have like consensus layer, executor, and like the transaction pool. Okay. So I want to highlight the features that are available in Substrate template node. You can go to the GitHub repo, download it, and then run it, and you can see like a blockchain in action like right away. So to do that, I would encourage you to use like our own like cloud-based playground for Substrate. So let me quickly go to this. Okay, so this is how the playground looks like once you like log in with GitHub. So the moment you choose a node template and then create it, so you'll be presented with like Substrate template node, which sort of runs right off the bat. So let me wait for a couple of seconds, and once it initializes, I'm gonna move on with the presentation. yeah, probably why I don't do like live demos of these. Um, but yeah, so I would defer that given the time constraint right now. And let's get going. Yeah, so this is something, if you don't want to like install stuff on your machine and just want to like check it out, um, check the node template that is available on the playground. All right, so if you are a Rust developer and you've never seen like Substrate, if you're brand new to Substrate, you'll realize that a lot of this code is not, it's not like Rust. Okay, there are plenty of like macros here that you should be comfortable with. Like initially it looks like magic, but the more you look deeper into like individual stuff, you get like accustomed to using them, right? So it's important to understand the structure the Substrate developers have created. So you have like really good documentation, which tells you exact reason like why you have code that looks the way it is right now. And there are plenty of tutorials that let you be comfortable with writing your code this way. So here I'm showing you like a pallet. Like if you were to create like your own pallet, meaning your own module that takes care of like some core functionality of your blockchain application. So you would structure it this way. There's a dedicated space for including the constants. There's a dedicated space for the runtime events, hooks, and like the extrinsics that you can call to make a call to this like particular palette. Yeah, and if you'd like to get an idea of the code in a specific palette, go ahead and check like the balances module, the balances palette. It gives you a good understanding of how to write a palette, right? So balances are, so this palette is for like accounts and transferring balance between the accounts and so on and so forth. All right, so you can innovate with the frame, the frame of Substrate. um, so the core primitives, so anything that starts with SP is like Substrate primitives. Okay, so you can make changes to this as well, although you should be like really adventurous to change something in here. So anything that starts with SC is like Substrate client. So this has to do with the Substrate node, the client capabilities, WASM execution and dispatching calls to the runtime, etc. And then you have frame. So frame is what we discussed, like all these pallets that are available for you to be included into like your blockchain. And then and then and then finally, like you can write like your own pallets. Okay, so this is the level of customizability like Substrate like offers to you. And then let me see if I have, yeah, I was really excited to show you something in here. Let's see if it works again, else I won't waste more time here. So basically, once this opens, you would see that the Substrate node template is up and running. It keeps adding like blocks to the blockchain, and you'd be able to explore like the code as well. But yeah, for some reason the stars haven't aligned today. I'm sorry for that. All right, so let's move on. And then finally, I want to focus on like the Parachain auctions, right? Like, why did like Polkadot choose auctions to begin with? Like, why can't a blockchain developer just plug into like Polkadot and sort of access its shared security? So there is a reason behind that. So we live in a permissionless world, right? So we want everything to be decentralized, but again, we want to ensure some sort of quality inside like the ecosystem. So we're talking about like bounded supply of resources that Polkadot can offer, and then there's potentially an unbounded demand out there, right? So somehow we would like to ensure that the projects in the ecosystem are trustworthy, given the prevalence of the scams that are out there. So we want the projects that become parachains on Polkadot to be vetted, to be backed by a significant community, and they sort of add value to the ecosystem as a whole. So that's why we have auctions, and again, like, these auctions are difficult to be gamed. So the reason for that is, to win a certain auction, you have to go through this candle auction procedure, a modified version of candle auction procedure on Polkadot. The way this works is, I mean, the original candle auction worked was, a candle is lit, people start giving their bids, and for some reason, the candle, is extinct, the flame is extinguished, or it crosses a certain line right there, so that the winning bid at that point is sort of going to like get the item. Now, the modification Polkadot made to this auction is that the candle is not visible to the people who are bidding. So they have no clue when exactly the flame is going to be extinguished. So they're going to be like honest with their bid of the number of dot tokens they would want to use to get like a slot on Polkadot. So it sort of combats the auction sniping. So the projects will be honest with the total number of dots they're willing to like lock to get like um, a slot in there. Yeah. So what happens is the project keeps bidding, and then the bids keep going on till what we call the ending period. So after the ending period, the winning block is retrospectively like picked. So what this ensures is this mechanism where the candle is not visible, and at this point, like, whoever has the highest bid is going to win that particular slot. And to bootstrap projects, like, Polkadot also has a mechanism called crowd loans. So crowd loans are permissionless. So if you're not a developer, in the audience, like, if you are someone who's interested in Polkadot ecosystem and would like to back a specific project, you can back it via like crowd loan. So if they open a crowd loan campaign, you can give dots to their campaign, and they don't hold your dots. So those dots will be used to secure the slot, and once the slot expires, um, slot lease expires, your dots come back to you permissionlessly. So nobody is going to uh, run away with your dots in a way, right? So all the ICO scams that you've heard back in 2017, 18, all of those problems are sort of eliminated by this permissionless nature of crowd loans. But yeah, so whoever has the winning bid at the termination block sort of wins the auction. And I'd like to highlight, like, the ecosystem is growing, and we have about like 160 projects that are actively building in the ecosystem, and we're looking forward for you to be part of the ecosystem as well. Please, like, attend the next session on Polkadot and Substrate as well. So that's when you'll get like a deeper dive into the technical aspects of it, and like building on Substrate. So with that, I sort of thank you for attending like today's session. If you have any questions, or something that sounded like really crazy, and if you want me to like explain it like further, feel free to like reach out to me. So that's my contact email, and I'm also available on Twitter. So feel free to reach out to me there as well. And with that, I conclude today's session. Thank you.